Hello, welcome to this course on automated unit testing basics. This course is for anyone who has some knowledge of computer programming but have no or limited knowledge of automated unit testing. This course is language, framework, and tools agnostic. Everything you learn from this course can be applied to any programming language with the use of right tools. We'll first look at what we are going to learn in this course. First, we will understand what is automated unit testing. Then we will move on to the structure of the unit testing. And then we will look at the setup techniques and verification techniques. Finally, we'll have a look at two different testing approaches that are very popular now. We will first start with understanding what is automated unit testing. Let's first understand what is unit. The term unit is very subjective, so it means different things to different people. In the context of testing, I like to think of unit as one or more lines of code that does something small but tangible to move towards achieving the end goal of the program. What do I mean by this? Let's look at an example of a very simple calculator program. In order to build a calculator, we need to build individual operations that are supported by the calculator. Each simple operations like addition, subtraction, multiplication and division are implemented using few lines of code, and these operations are unit because these are small but tangible steps needed to build a calculator. However, we cannot say all these operations supported by a calculator are made up of single unit. There are some operations like average, percentage, etc. are not simple ones and they are implemented using group of operations. For example, average is implemented using addition and division. We need to understand here that unit is loosely defined term and subjective. In most cases, you refer a small function or subroutine as unit, but it is not always true. There may be functions or subroutines that are made up of group of units. So unit testing is taking a small piece of code that is written to do something small but tangible and test it to verify whether it is working as expected or not. Automated unit testing means the unit testing process is automated by writing code. So the tests are written once and run as many times as we like without any manual overhead. For example, the tests you need for individual units of calculator program are called unit tests. If those tests are automated with code, then you can refer to them as automated unit tests. Going forward in this course, I will be referring to unit of code we are testing as system under test or set, and the automated unit test as simply unit test. Now we will see why are we writing unit tests. We can find many reasons for writing unit tests. There are three reasons that stands out in my opinion. The first one is verifying the correctness of the code. I don't think any good developer will just write code and say that the work is done. They will test it, either via manual steps or by writing automated unit tests to verify whether the implementation is correct or not. The second one is safety net or feedback mechanism for changes. Once the code is written, we may need to change it for various reasons, ranging from changing business requirements to simply to fix a bug in the code. When we want to change code, we need to be very careful to make sure we are not introducing any bugs or unintended side effects. The term used to refer to bugs or unintended side effects caused by code change is regression. Generally, the bigger the program gets, the challenging it becomes to keep regression issues under control. This is where unit tests are really useful. If we have good, solid unit tests covering the current code, then we will be able to get immediate feedback on any change that causes regression issues. The third reason for writing unit tests is documentation of the code. By providing suitable name and description for the tests and keeping it covering all the scenarios of the set, the tests can be used as a documentation or specification by developers. Now we will look at what is good unit test. When writing tests for any block of code, it must be comprehensive and cover all the scenarios. If we write test for most obvious scenarios and don't cover the less common scenarios, then we don't know how it is going to behave on those untested scenarios. So we will look at some of the qualities of the unit tests now. The first one is quick to run. When running unit test, we don't want to wait long because each of the tests we write targets only few lines of the code. We could easily end up with hundreds if not thousands of tests even for a small program or application. Our tests must be extremely fast to get feedback quickly. So we should try to avoid anything that will slow down our tests. When it is not possible, we should at least be able to keep the slow running tests separate and run them independently without affecting fast running tests. The next quality is repeatable. We should be able to run our tests repeatedly without any manual interventions. This means anything that our tests need should be done in the test itself. For example, if we need our application to be in a particular state for running a test, then the test itself should bring the application to the desired state as a prerequisite, perform the steps necessary for the test, and do any necessary cleanups at the end of the test. The next quality of good unit test is it should be focused. We don't want one test trying to verify too many things. Each test should verify just one thing. For example, if we have a function to validate bank account number, then we should try to create one test for each validation rule. That is, one test to verify the account number whether it is not null or empty, and another one to check whether it has exactly 8 characters, and finally one more test to verify whether it contains only digits. So each rule should have its own test. The next quality of good unit test is isolated. Any test should not depend on any other tests. Although it is very common for a function or an object to depend on other functions or objects, the tests we write targeting a particular block of code should not be affected if the behavior of any of a dependent function or object changes. The final quality of good unit test is self-validating. Each test we write should give us the feedback at the end on its own. We should not rely on anything other than the test itself for the result. Now we will look at other types of automated testing. While unit tests target small piece of code, we have other types of tests that generally focus at higher level than unit tests. Two examples of such type of tests we have are integration and end-to-end tests. Generally, unit tests focus on small piece of code without considering the behavior of dependencies they have, usually with the help of fake dependencies. This means we will be able to verify whether the target code works on its own or not. But we will not know whether it is going to work correctly as part of a bigger program. While this is the correct approach for unit tests, it doesn't cover verifying the behavior with real dependencies. Integration and end-to-end tests fall under this category where SUT will be tested with real dependencies. Integration tests aim testing SUT with one or more real dependencies and may use some fake dependencies if required. On the other hand, end-to-end tests try to test the application just like how end user will use it. End-to-end tests generally use publicly accessible parts like UI or API for testing. While it is not common, end-to-end tests can use fake dependencies if required, but it should be kept to minimum. When writing tests for any application, we should use integration and end-to-end tests along with unit tests. People use a pyramid diagram to show the distribution of these three types of tests. As we can see in this diagram, unit tests should be the majority. We should use integration and end-to-end tests as and when they are required, but they are small in number compared to unit tests. Now let's understand a bit more about system under test or SUT. The implementation of set that are the target of our unit test can be direct implementation, indirect implementation, or combination of both direct and indirect implementation. Let's understand a bit more about these implementation type. First, we will start with direct implementation. If a function or a piece of code is direct implementation, then it will take 0 or more inputs and provide some results or cause state change with very little or no dependencies. Examples of direct implementations are functions that implement individual operation of a calculator program like addition, subtraction, etc., or function that creates new student object, or a function that validates bank account number. Now we will see what is indirect implementation. Normally, a function or piece of code falls under this type when it gets something done via one or more of its dependencies rather than doing it on its own. Examples of indirect implementation are reading or writing data in database by calling functions in the database driver, or validating the account number by calling a function that provides the validation functionality. Some implementation may be combination of both direct and indirect implementation. It is good to be aware of these types because we might need to use different techniques for testing depending on their implementation type. Now we will look at the structure of the unit test. If you look at any unit test, they will have some of the steps that we are going to see. One of the first step in writing unit test is setup. In this step, we will prepare test data and dependencies for the test. For example, we will replace any real dependencies with fake ones and define set of good test data as part of the step. However, this step is not necessary for all the tests. This step is commonly referred to as arrange or fixture setup. The next step is running the set. This is the step that runs the set with test data and or the fake dependencies. This is a mandatory step for any unit test. This step is commonly referred to as act or exercise set. The third step is verification. This step verifies the result of running set under test condition. This is a mandatory step. This step is commonly referred to as assert or verify outcome. The fourth and final step is called cleanup. This is optional step and needed only when any cleanup is required after the test run. This step is commonly referred to as fixture teardown. Let's look at one of the popular acronym when writing unit tests. It is AAA. AAA stands for arrange, act, and assert. Because cleanup step is not very common, it is omitted. Here is an example of AAA pattern test. It has arrange phase and then act phase and finally the assert phase. Now let's look at some of the setup techniques. The first setup technique that we are going to see is simple test data. With this technique, when we need data, we just create variables with the data and use them within the unit test. Consider an example of testing a function that adds two numbers. To test this function, we need two input data. We can simply create two variables with the data in our test function and use them as an argument for add function. Next technique is data-driven test. When we want to test set, we usually want to test with different set of data. It is not ideal to create one test for one set of input data. This is where data-driven tests are helpful. Consider the same example function that adds two numbers. To be thorough, we need to test this function with few different set of data, including but not limited to negative numbers, positive numbers, and zeros. Although it will be descriptive and easy to follow when we have one test function per test data, it requires more development and maintenance effort. Better solution is to create one test function that we can run with a different set of data. This is what we call data-driven test. An example of data-driven test would look like this. Here we have a type called data test and it has 3 members in it. The first 2 members are for the input and the final member is for the result. And within the test function here, we create 3 different test data and then we run the set using each of those test data and finally verify the result of the function call with the result we have in our test data. We need to understand that the actual implementation of data-driven test will be different based on the language and framework used. The next technique we are going to see is called fake test dependency. It is very common that the set depends on something else. The dependency could be anything like another function, object, or external system, and we may not be able to control their behavior all the time. A good unit test should not be affected by the changes in the dependencies of set. So, a common technique is to replace the dependencies with fake version that we can control. For example, consider a function that takes age of the passenger and prints whether he or she is eligible for senior citizen discount when promotion is available. The function which tells whether the promotion is available or not is defined in another module and we do not have control over its behavior. However, in order to test all the branches and the conditions of is discount available function, we need to be able to control the result of is promotion available function. So we first create fake version of is promotion available function in fake promotions module with an option for us to control the result. Then replace the promotion with fake promotion inside the test. That is it. Now we have replaced the original dependency with a fake dependency that we can control in our test. Depending on the language and framework we use, the way we replace the real dependency with fake one will be different. Next and final technique we are going to see in setup technique is called mock dependency. While fake dependencies are really useful for unit testing, they lack in features like tracking function call, intercepting arguments, and other things that makes unit testing easier. Mock dependency is a dependency which offers all the benefits of fake dependencies and more features to make unit testing easier. It is not going to be easy to create and maintain mock dependencies. This is why we generally use mocking libraries to create mock dependencies. If we take the same passenger discount example that we have seen previously, we create, setup, and use mock version of is promotion available like this in the tests. So this is very similar to fake dependencies, but with the mocks you will have additional features that will help you with writing better unit test. Again, depending on the language and framework we use, the way we create, setup, and use mock dependencies will be different. Okay, now we will look at some of the verification techniques that we can use. The first technique we are going to look at is called result verification. We use result verification technique when the tester receives the result by running the set. Consider an example of testing a function that adds 2 numbers and returns the result. We verify the correctness of this function by simply checking the result returned by the function. So the next technique we are going to see is state verification. State verification is similar to result verification, but rather than checking the result of set, we will check the state of an object or something similar. Consider an example of testing a function that closes the database connection. When we call this function, it is not going to return anything. Instead, it is going to change the state of isOpen field. So, we need to verify the state of isOpen field to ensure the correctness of the close function. The third technique we are going to look at is called interaction verification. Interaction verification is completely different from result and state verification. With this technique, we'll be checking whether an interaction under a specific condition has happened or not. Consider the example below. The database manager module offers a function to close database connection. but it neither returns any result nor changes the state. All this function does is that it calls a function in database module. So the only thing we can do to verify the correctness of this function is to check whether it calls close function in the database module or not. Now let's look at two different approaches when it comes to writing unit tests. The first one is called test-driven development. Test-driven development is a popular approach for writing unit tests. With this approach, we write a test first, see it fail, then write production code to make the test pass. Typically, we first take a small requirement, write failing test, write production code to make the test pass, and finally refactor the code. Then we will repeat the whole process again. So this test-driven development is also referred to as TDD. It is claimed that TDD helps to write code that is simple, flexible, and just enough to satisfy the requirement. The next approach is called test-oriented development. In test-oriented development, it is not important to write test first, but it is important to write test while writing production code. Typically, we'll take a small requirement, write production code, then write the unit tests, and finally refactor. And we will repeat the whole process again with this approach. Personally, rather than just sticking to one of these two approaches, I'd like to mix them depending on the situation. This is the end of the course. Thank you for watching. I'll see you in the next video.